The first question being asked is, what is the average velocity? Our delta t is 3 seconds because we start at 0 and end at 3. Our v1 is 5 x hat meters per second. And we get 5 on the hypotenuse right here because the magnitude of v1 remains constant on this part when it takes the right turn. So if we have 5 here and then the theta is 30 degrees, we have this speed times the sine of theta, and then the speed times the cosine of theta. So our sum of the force in the x direction are speed times cosine theta, which is 5 times cosine 30, which gives us 4.33 x hat meters per second. And then in the y direction, we have speed times the sine of theta, which is -5 because it's going down, times the sine of 30 degrees, which equals -2.5 y hat meters per second. So that gives our average velocity of 4.33 x hat minus 2.5 y hat meters per second. And the second question being asked is, what is the average acceleration between 0 and 5 seconds? And because you have a change in velocity between times 0 and 5, you have a change in acceleration. So our formula for the average acceleration is delta v over delta t. And if we get our y2 minus our v1 minus v2, our v2 minus v1, my bad, it's going to be 4.33 from this problem, x hat, minus 5 x hat from the beginning, plus -2.5 y hat from the average velocity over the change in time, which is said 5 seconds. So you'll get from the x's being subtracted, you get -0.67 x hat minus 2.5 y hat meters per second divided by 5 seconds. And our average acceleration comes out to be -0.134 x hat minus 0.5 y hat meters per second squared.